Right, page 167, number 45. Use a computer algebra system, that means use a calculator, to graph the function and approximate any absolute extrema. Use the graphing calculator to find any critical numbers, and use them to find any absolute extrema not located at the endpoints. Compare your results to part A. So basically, work the problem, but put it on a calculator and see if it matches up. Use a calculator to check your answers. Would be an easier way to say that. So f prime of x would be, come on, 3.2 times 5. So that would be 15 plus 1 would be 16. X to the fourth plus 15x squared minus 3.5. Yep, that's terrible. So I'm going to jump ahead and just put it in the calculator and see what is going on with this thing. Although I guess what it means is I could use my calculator to find the zeros of the derivative. And I'm really only looking at between 0 and 1. So I'll go -1 to 2. And the y values don't really matter as long as I'm catching 0 in there. So let's see. So, second calc, 0, left bound, right bound, guess. So at 0.4398, so 0.440, there is a f prime equals 0. So that's a critical number. Right, from the calculator. Now let's graph the original and see if that kind of matches up with what we think. 3.2x to the fifth plus 5x cubed minus 3.5x. So my guess is that this point, that minimum is probably at x equals 0.44. Second calc. Minimum, I don't know if you've seen this on the calculators. It'll find the minimum for you. Left bound, so just get to the left of what you know is the valley point. To the right of it. Guess something and let's see. Sure enough, 0.44. There's a minimum there. So that question is kind of strangely worded, but it's just trying to get you to do a little bit of calculus by hand, a little bit of calculus with your graph, and see that it kind of matches up. So I think that's all it's really asking for number 45.